This paper presents a novel approach to mitigating cross-domain bias in large language models, LLMs, by employing an unlearning-based method. The authors propose mask language modeling, MLM, unlearning, which selectively unlearns harmful content within the text by forgetting only toxic or biased tokens. This technique is inspired by prior successes in unlearning privacy-sensitive data and aims to preserve language modeling capabilities while reducing bias and toxicity. The authors review existing debiasing techniques for LLMs, highlighting their contributions and limitations. These include counterfactual data augmentation, CDA, sentence debias, iterative nullspace projection, INLP, and SELFDEBIAS. However, these methods often focus on mitigating specific types of bias and overlook the interconnected nature of bias across domains such as gender, race, and religion. The proposed MLM unlearning technique uses gradient ascent to maximize the loss function for specific undesirable patterns in the training data, thereby minimizing the likelihood of such patterns. The loss function is formulated as equation 1, where LM unlearning equals log p, she, x, she, and she denotes the toxic or biased token to be unlearned. P, she, x, she, represents the probability of the masked ith word given the surrounding context x, she. Experimental results demonstrate the effectiveness of this approach in diminishing bias while maintaining language modeling abilities. Surprisingly, the results also unveil an unexpected potential for cross-domain transfer unlearning. Debiasing in one bias form, e.g., gender, may contribute to mitigating others, e.g., race and religion. This finding suggests that unlearning-based methods can potentially eliminate a wide range of bias and toxicity, offering a promising direction for comprehensive and universal debiasing solutions. The research paper discusses a novel approach to mitigate biases in language models by using mask language modeling unlearning. The study focuses on gender bias, utilizing the dynamically generated hate speech dataset to identify and mask toxic words. The experimental setup involves training GPT-4 to identify bias and then masking these words, followed by unlearning using GPT-2. The evaluation uses various datasets, including Wikitext2, Crow-S pairs, and StereoSet, to assess language modeling performance and bias scores. The results show that the proposed method effectively reduces bias without compromising language modeling capabilities, with an unexpected generalization to other bias domains like race and religion. This transfer unlearning phenomenon suggests potential for broader applicability of the methodology. The study highlights the balance achieved between debiasing and preserving language modeling abilities, making it a promising approach for mitigating biases in language models. This research paper focuses on the issue of bias in language models, specifically exploring the concept of unlearning and debiasing in pre-trained language models. The authors discuss the limitations of existing debiasing methods and propose a new approach to address these limitations. The paper references several existing studies on bias evaluation and debiasing techniques for conversational language models, including Reddit bias, real toxicity prompts, and StereoSet. These studies have demonstrated the importance of evaluating and mitigating bias in language models. The authors highlight two significant limitations of their study: the reproducibility of the mask rules set by GPT-4 and the invalid unlearning of tokens following the mask. They propose that future work should establish explicit mask rules to reduce reliance on heuristics and enhance reproducibility. Additionally, they acknowledge that their method effectively removes the association between the context and the masked token, but the remaining words after the mask become irrelevant, presenting a major challenge for future research. The paper also presents an example from the Crow-S pairs dataset, which is used to evaluate social biases in masked language models. Furthermore, it illustrates a data entry from the StereoSet dataset, which measures stereotypical bias in pre-trained language models. The authors present perplexity results across different unlearning steps, demonstrating the efficacy of their method in preserving language modeling performance while reducing undesirable bias. The results show a slight increase in perplexity on the Wikitext2 dataset and a substantial rise in perplexity for both the DGHS training and testing segments, highlighting the effectiveness of their approach in reducing toxic and biased content.